Hello everyone, this is homework 16, the last homework for unit test number 3, and here we solve systems of linear equations graphically. So we define a system of equations is basically just two straight lines, or two lines on the same set of axes. And if we have a point of intersection, it's an ordered pair that's a common solution, and it satisfies both of the equations. So graphically, the idea is you've got two straight lines intersecting, this point where they intersect. Okay, so this is your point of intersection. And we refer to that as being the common solution. So initially, in the first few exercises, we're just going to be asked to determine if an ordered pair is a solution to the system. And if it is, it has to satisfy both lines. So I've distinguished between the two lines here. I call them L1 and L2. And here's the first point we want to test. And remember, this is an ordered pair of x and y values. So let's say for L1, we substitute. And we have x is 3, so 3 times 3 minus y, which is 6. Is that equal to 3? And that's 9 minus 6. A question mark above, is it equal to 3? And 3 equals 3, so it checks. In other words, that point does lie on L1, but what about L2? So we substitute down to L2. So reading L2, we have x, which is 3, plus 6 times y, which is 6. Is that equal to 20? And we get 3 plus 36. Is that equal to 20? And obviously it's not. 39 is not equal to 20. So therefore, 3, 6 does not satisfy this equation. So it does not lie on that line. It's okay that it lied on that line, but since it doesn't lie on this line, then we would conclude that 3, 6 is not a common solution. So it has to be a solution to both. So let's check out 2, 3. For L1, again we substitute, and we have x is 3 times, or we have the equation 3x minus y equals 3. So 3 times x is 2, minus y is 3. Is that equal to 3? And we get 6 minus 3 equals 3. So 3 equals 3, and it checks. That is, it does lie on that line. Let's check out L2. And now we're using the equation x plus 6y is 20. X is 2 plus 6y is 3. Because again, this is the ordered pair of xy values, if you'd like to label it. Is that equal to 20? And we get 2 plus 18. Is that equal to 20? And yes, 20 equals 20. So it checks. So that point lies on that line as well. So then we could say that the point 2, 3 is a common solution. Okay, so it has to satisfy both. Now, if we have to solve graphically, we can graph both lines on the same set of axes by any method we want. As we know, there's 3 ways to graph: table of ordered pairs, intercept method, or the slope-intercept method. And whatever one you want to use is fine. Doesn't matter. You're not going to be told which method to use. But there's 3 cases we can come across. We'd have one solution where the lines intersect, and that's your ordered pair. That's the common solution, point of intersection, as we mentioned earlier. You could actually have no solution. No solution would be if the lines are actually parallel. Because if you have parallel lines, they don't intersect. Or you could actually have an infinite number of solutions. And an infinite number of solutions is you have a line, but then you have another line, which is basically the same line. So you got the line on top of the line, and they intersect everywhere. So in other words, it's the same line. So those are the 3 possibilities. Now, as we go through solving these, we're going to be obviously seeing the graphs, so therefore we'll be able to determine what situation we have. The classic situation, of course, would be one solution. I'll label my axes here. Consider graphing L1. I'll recopy x minus y equals -2. And I'm just going to set up a table of x and y values. And I'm actually going to use the intercept method because, remember, when you have x and y on one side and a number on the other side, a constant on the other side, typically the intercept method does work well. So I'm going to let x equal 0. I'll just do the work underneath. So when x is 0, then we have 0 minus y equals -2. So minus y is -2. That's really a -1y, right? If you want to write it in there. And we talked about this before. You could think of dividing or multiplying by -1. And we get, I'll do the division by -1. We get y equals 2. So 0, 2 is an ordered pair for that line. And using the intercept method, I'm going to let y equal 0 and find out what x is. So when y equals 0, we get x minus 0 is -2. So immediately x is -2. Okay, so let me actually plot that line first. 0, 2 be the y-intercept, and -2, 0 the x-intercept. Right, now, when you're doing this by hand, you do have to be very careful. Make sure you line up the points neatly. So that looks pretty good. When you're doing this on My Math Lab, it's actually kind of nice because the way you graph the lines, you can't really make a mistake. When you do it by hand, you really have to try to be accurate because otherwise it might not look like the point that it is because of just, minor shifting of the line. But in any event, we have to graph L2 now. So I'll recopy it. And again, the intercept method, I think, is the best method here as well. So we'll do the x and y. Let x be 0 on one occasion, let y be 0 on the other occasion. Show the work here. When x is 0, 0 plus y equals 8. Kind of silly to even show that substitution, right? But by inspection, you could say y is 8. And now we'll let y equal 0. And when y is 0, we get x plus 0 equals 8. And again, kind of silly to even show the substitution, because by inspection, x is 8. Okay, so we have 0, 8, and 8, 0. So 0, 8 is right here, and 8, 0 right here. Okay, again, I want to be as accurate as I can in terms of lining these up. And let's see. That was a good sketch. You can see there's a point of intersection. And what we have to do now is read that point. And it looks like the point is 3 and 5. So the common solution is the point 3, 5. And you can check this by substituting into each line. Just doing it mentally, x is 3 minus y is 5. 3 minus 5 is negative 2. And x plus y, 3 plus 5 is 8. So we're pretty much guaranteed we did that correctly. Okay, so that's how we do that. Now, here's a situation where in both equations, y is given explicitly in terms of x. Choose your method. I mean, maybe if you like the slope-intercept method, that's fine. But I think a table of values is probably the easiest way to go. Because all you need is 2 points, and one of them always we're going to choose 0 for x, right? So when x is 0, we get y equals 0 plus 5, where y is 5. So that was easy enough. And then just pick any other value because y is given explicitly in terms of x. I mean, you could use the intercept method here, but I'm just going to choose a different value of x. And I'm going to say x is 2. It doesn't matter what you pick. If you want to pick y is 0 and use the intercept method, that's fine. But if x is 2, 2 plus 5, or 7. Okay, so let's graph that. So 0, 5, that's our y-intercept. Right there. 2 and 7. Looks like it's right there. Draw the line. Again, when doing this by hand, you have to be fairly accurate. Because if we don't pass through those points identically, then you can get the wrong line. Oh, I could have actually labeled these, right? But this was with like L1 and L2 maybe is the easy way to label it. So there's L1. Oh, I just went up here, I'm sorry. I just went up here and labeled the lines L1 and L2. Okay, so that's L1. Now for L2, y is negative 4x. So again, I'm going to go to a table, let x be 0, and when x is 0, you can tell by inspection, you don't need to substitute anything in here. Y is negative 4 times 0. I'm showing it literally though. So y is 0. So that's our origin. And then pick another value of x. Doesn't matter what you pick. Let's do 2 again. So when x is 2, y is negative 4 times 2, or y is negative 8. So 2 and negative 8. So 2 and down 8 right here. And the origin is 0, 0. Okay, now I have to be a little bit careful. When we graph these, you can get the ordered pair. Which is the point of intersection. Again, when you're doing this on my math lab, it works out perfectly. But here it looks like that point is negative 1 and 4. So the common solution is negative 1 and 4. And again, you could double check. Go to the equations. 4 is y. Negative 1 is x, so negative 1 plus 5 is 4. And again, 4 is y, x is negative 1, and negative 4 times negative 1 is 4. So you see that has been verified. Alright, so then the last page of notes for this homework. We have 3 more examples. And we see the first one. You might be able to tell by inspection something's funny about this one, because the equations look almost identical except for the constant term. That's the only difference. But let's say we don't know, and we're just going to go through our process. I'm going to use the intercept method again. So x is 0 into L1, which is x plus y is 5. 0 plus y is 5, so y is 5. So 0, 5 is a point. And then I'm going to do when y is 0. And again, x plus y is 5. Oh, negative 5, I'm sorry. So that changes all the 5s to negative 5s. Make sure you make that correction. Okay, so then when y is 0, x plus 0 is negative 5, so x is negative 5 as well. Okay, so we've got a y-intercept of 0 and negative 5, x-intercept of negative 5, 0. So those are the 2 points. And we'll sketch the line. See how I was a little bit off there, some of that might cause an issue in the end, but let's just go with it. That's all one. Oh, here, let me go back to that last example. I got a little bit excited. After I graphed L2 here, I didn't label it. Not that it was really necessary, but just to be complete. Okay, in any event, now we got to graph L2. And now x plus y is 0. Now if you use the intercept method here, let's see what happens. If x is 0, then we get 0 plus y is 0. So y is 0. But I could tell by inspection that if I let y equal 0 to try to use the x-intercept, well, you could tell right here, if you let y equal 0, you're going to get x equals 0. So therefore, we'll have to pick a different value of either x or y. I'm going to go with x. And I'm going to say 2. Again, it doesn't matter. I'm just creating a table of ordered pairs. And then we have 2 plus y is 0, solving for y, subtracting 2 from both sides, we get y is negative 2. So 2 and negative 2 is right here, and we have the origin right here. And now, if we sketch that line, we see that they are parallel. So there's L2.